You're listening to Let's Talk Creation with Todd Wood and Paul Garner, the creation show where we learn, grow, and worship.
Well, welcome back to another episode of Let's Talk Creation with Todd and Paul. I am Todd Wood.
And I'm Paul Garner.
And I am here to remind you, before we get started, like and subscribe and share this with your friends, do all that good stuff. If you're on YouTube, hit the like button. If you're on some other platform, do consider leaving a review or some kind of recommendation. We would very much appreciate that. If you're not subscribed, you should go ahead and hit that subscribe button. Click the bell. There's a bell somewhere, right? That that buzzes you about when there's a new episode. You should do that too. And we thank you, everyone who is a faithful supporter of Let's Talk Creation. We know we have at least hundreds of people who are regular listeners and watchers of our work, and we do appreciate all of you being here. And today, we've got quite the episode. This should be really interesting. Yeah. So let me see if I can sort of set the stage. There are apparently creationists in Europe too.
Yes, that's absolutely right. Yeah.
Yeah. So
we've been around longer than you have.
Indeed, you have. Yes, I believe the oldest creationist organization in the world is actually British, as I recall.
That's correct. Yeah.
Correct. So it's usually portrayed as an American problem, right? So people talk about all those creationists in America, and sometimes if they know about Ken Ham, they'll know about creationists in Australia too. But Europe doesn't usually get the same exposure, which is interesting. I'm not sure what's going on there. Not quite the same level of excitedness. I'm not sure what it is. But the point is, there's a creationist meeting. There's actually several creationist meetings that go on every year. And one of those is a geology meeting, Paul, that you went to last year. Could you tell us a little bit about what that meeting was and what it involved? Yeah, just set the stage a little bit for us.
Yeah, so there's a German creationist organization called Zoutewelle, which means word and knowledge. And they've been active for a long time. And they've got quite an active program of events, and they hold an annual geology workshop, which I've been involved in for the last several years. And I've got to know lots of the guys there. And in September last year, their annual meeting was actually not held in Germany. It was held in France. We were close to Paris, not too far from Paris. And that we had a conference theme for the first time, at least while I've been attending. And the theme was the Paris Basin and the radiation of the mammals in the tertiary. Now, a lot of our viewers probably are going to be thinking, what on earth is that all about? So that's what we're going to explain today. That's what we're going to be talking about. So it was a great meeting. We have a field trip. We go out and look at some rocks out in the field. We visited the museums in Paris, and we had some talks and fellowship together. So it was a great time. And I always enjoy being there.
All right, then. Well, so today's episode, we're gonna extend that theme of the Paris Basin, and we're going to try to learn what that tells us about the history of creation and the flood. And we've got two special guests, not one, two. So this is kind of a jumbo episode. So first guest here is Tom Zoutewelle, who is a Dutch creationist from the Netherlands. And Tom is an independent researcher, geologist, and welcome, Tom.
Welcome to you.
All right. And our second guest, another one of the conference attendees, and a familiar face around these parts on our podcast. You've seen him before. You'll probably see him again. It's Marcus Ross from Cornerstone Ed Supply. So Marcus, welcome.
Hey, thanks for having me on again.
Yeah.
And I suppose that already sounds like an invitation to come back for another episode. So thanks in advance for the next one.
You just keep coming back. I mean, see, you just keep saying yes when we ask you. This is the problem. So if you don't want to keep coming back, say no.
It is a problem. Yeah, we gotta Like a bad penny, I just always turn up.
There you go. There you go.
Yeah.
All right. Well, let's get into the episode. I've got my notes here on my phone as usual because I want to explain to everybody watching, and I want to explain to all of our guests here. I am not an expert in geology. I'm good at faking saying geological things, but I don't know geology very well, and I don't know paleontology very well. So bear with me as we work through all of this. But I think we're going to have a really interesting time and try to keep this all pretty understandable to all our listeners. So how about we kick it off with the question of the day, and that is, what is a basin? So Tom, could you help us out by explaining the basics of a geological basin? Is it like an actual basin, like a bowl?
Well, it's a very old term in geology. It's actually where if you look at a continent, then on every continent there is the lowest point, and where we have a lowest point, that it will be a point of deposition, the depositional point. So the water normally runs to the lowest place. And when it's carrying sediment, little particles of sand and other material, they will be deposited at the lowest point. So you get an accumulation of sediments of one layer, two layer, another layer, a number of layers. And that occurred around Paris. But there's more to it, because in the end, it is not only the sedimentology who is ruling that process, but it's also the tectonics, the movements in the earth. So where you have a central point, which is the lowest, it turns out that around this point there are higher points, and that is also the case in France. You have what we called in the south the Massif Central, and in the east the Vosges, and in the west the American Massif. And in the north, the Ardennes Massif. They are all surrounding this Paris Basin, and also causing that to be the lowest point, the Paris Basin. So that's basically the whole project, the whole thing.
So a basin then is literally like a big low point on a continental piece?
It's like a bath, and all the water is running to that bath to the lowest point, and then it drops the sediments, and then all what's in the water, also the fossils, are being preserved as well. So that's basically the situation. Very easy.
Okay. Now, are basins common? Are there a lot of basins?
Well, the funny thing is, a good friend of mine, Ariel Roth, he mentioned to me many times that you will find a lot of sediment on the continents and not around the continents. And that's a funny story. So actually, we do find a lot of basins on the continents. You have to make the conclusion that the sea was covering the continents, and therefore we have basins on the continents. And that's, of course, a very intriguing point for geology in general.
Yeah, that's very suspicious. Why would because we don't have seas covering continents today. That's rather unusual. Yeah. I may not know much about geology, but I have noticed that.
Good.
Yeah. All right. Well, so can you give us a little bit more then about the actual Paris Basin itself? So, what's the geology like there in that Paris Basin?
Yeah, well, let's start off with the uppermost layer of what's underneath, and that's actually the Cretaceous. So actually, the basin was, as a basin, active before the time. So the Jurassic and the Cretaceous were also more or less deposited in the same way. And the Cretaceous was a very special point in time because there was a high stand of the sea level. So there was a lot of water over Europe, and we had a sort of sediment, a sort of ecology, which produced very special sediments, very clean limestones with a lot of small animals. And that was there was a standstill in sedimentation for a period of time. And actually we were able to witness that period because it showed up with a very special sort of sediment, which is called microcodium. It is actually a bit of a reworking of the chalks you see in France, but also in the UK, and Paul is going to tell us about that. So that's the first part. The starting point is the Cretaceous, where you had this high stand and there was no sedimentation going on for a period of time. It was what we call a hard ground, some sort of a paleo hard ground, and there that was the boundary between the Cretaceous and what's lying on top of that, and that's what we call the Cenozoic. The Cenozoic is containing two major portions. That's the Cenozoic, the Tertiary, and the Quaternary. Now, the Tertiary was our main concern because in the Tertiary we find sediments in which the mammal history of the Earth is being preserved, and therefore the theme of the conference was called the Tertiary and the radiation of the mammals. That was the theme of the conference. And in France was the first area where this was really studied. So we have the famous French geologists like Cuvier, and he was one of the first who actually saw these fossils and described them, also recognized them. And it was his work that really was the beginning of paleontology. Cuvier was a very special man because he acknowledged that fossils, when you find fossils, they are probably being deposited in a catastrophic environment. So he was definitely a catastrophist. And that's interesting because that brings us to the real foundations of geology. So there is a lot of catastrophism in geology, and that was pushed away for a long time by science. And when I studied geology, when I started in the 80s of the last century, it came up again, and it was really thrilling to see that geology was reinventing catastrophism, and from that time on, we had a very interesting time in geology. So these are historic. This is a very historic environment if you look at the basin of France.
So you mentioned the So there's the Cretaceous, and then the Cenozoic material on top of that. Is what's under the Cretaceous then? What's under there?
Well, that's the Mesozoic. So you have the Jurassic, also very mostly marine sediments, and underneath that you find the Paleozoic. And the Paleozoic is not reaching the surface in the Paris Basin. You have to go to, for instance, Belgium. So I organize excursions to Belgium, to the Ardennes. Many times I've done a lot of field trips. Very interesting. But in the Paris Basin, in the outliers, so in the more distal parts, you will find the Jurassic and the Cretaceous. And when you go more inward, this is the saucer. In the center, there's a lot of Tertiary. And when you go outside, you find the older layers. That's typically for an anticline. In the anticline, if you go to the center, you will have the younger layers, the younger deposits. If you go to the outside, they will getting older.
So it looks like. So
it might also add.
Yeah. I was just going to say it looks like a bullseye on the map, as I recall.
Yeah, sure. Yeah, it is it's very beautiful. I'd like to mention one thing because I also already mentioned you had a high stand during the Cretaceous. Now in the Eos, in the Tertiary, you will see that the sea level is dropping. So you get more and more terrestrial deposits, and those terrestrial deposits are of interest because there are actually you can find the fossils were interesting in the mammals. But from time and again, this part of France is being inundated. So the sea was coming in, so there was a partial transgression. We call it a transgression, but the sea is rising and entering the continent. And I think 4 times actually it entered France. And in those deposits, you find these beautiful fossils here. Those are they have been living in the sea, so they're marine sediments and marine fossils. And of course, they're also very interesting. Now, the problem with geology is that many times we have problems when we have to correlate terrestrial and marine sediments because it's land and sea. So that's very difficult for geology. We have to try to solve that. But the Paris Basin is actually you're able to do a good correlation because the sediments lie next to each other. So that's very good.
Yeah. So this is so Marcus. Let me turn to you here, because this is something we American creationists fight about a lot, and that is this order of the fossil record issue here. I mean, it sounds to me like what Tom is telling us is that we have a place here where there are a whole bunch of these layers of the conventional geologic column that are all in the right order in one location, that it's not fabricated from a bunch of different places, but it's actually right there. Is that what I'm hearing? Am I hearing that correctly?
Oh, you're going to make me say yes to that? And yes, that's exactly right. So,
Okay.
one of the things that you guys have all certainly seen, right? At Cornerstone, we have our biblical geologic timescales that we include in our geology kits. And on those timescales, sorry, the light's reflecting off of this nice glossy laminated one that we put in the kits. And yes, they're fancy. So we've got those names like, up over here, we've got Cretaceous, Jurassic, Triassic. Down here is the Paleozoic that Tom had mentioned. And the Cenozoic is all up in this yellow. It actually starts over here, but, I needed more space to put the names on, which is why it drops down a bit over here. And so what we see in the Paris Basin on the field trips that we got to go on was we started looking at Cretaceous deposits and very upper Cretaceous deposits. Tom showed off a couple of fossils that he got from the Eocene, and we'll talk more about those. But I got a couple of different types of fossils from the outcrops there in the Campanian, the upper Cretaceous. So I got a little echinoid. It's kind of like a sea biscuit, sea urchin sort of thing. And I got a brachiopod there as well. So I got 2 each of those, which was fun to be able to go to these absolutely classic localities. I mean, these are the sorts of places that in the history of geology between England, France, Germany, primarily, were the places where this geological column was first established. So as Tom was saying, right, Paris is in this basin that flexes down, and you've got bowls within bowls within bowls. You've got, one bowl of Jurassic sediments, bowls of Cretaceous sediments, and then internal stacked bowls of Eocene, Oligocene, etc. in the Cenozoic. You don't have any Paleocene there. There's kind of an erosional gap, and you don't have any Maastrichtian from the very last of the Cretaceous. So there's a little bit of a space there. But nonetheless, you've got these stacks of bowls. Now, where I did my master's degree in South Dakota was a great opportunity to do a test case to see whether or not the stuff that was established out in England and continental Europe actually had any correlation, literal correlation, to what we see in North America. So I went to South Dakota School of Mines and Tech, and that's out in Rapid City. And rather than a basin, what the Black Hills of South Dakota are is it's a dome. It was a whole bunch of rocks that punched up through what were flat-lying sediments and tipped them all up. So it's like upside down bowls upon bowls upon bowls. So looking at it from a geological map, both of these look like bullseyes, which is pretty cool, but they're inverted from one another. In the Paris Basin, the closer you get to the middle of the basin, the higher in the stack you've gotten, right? Because the sediment keeps going down and filling and filling. And so you've got the edges with the old stuff, and you've got the middle with the younger stuff. In South Dakota, the opposite happened, where you got these layers and then things got punched up. The old stuff was brought up to the middle, and the further you go from the outside of the Black Hills, the younger and younger the sediments get. And it turns out that the order and the pattern in the sequence matched between what was discovered and the relationships seen in continental Europe and England. And then when we go to the United States, we find the same groups of rocks with characteristic types of fossils in the same order, even in inverted in sections where that order doesn't go in the same out to in pattern. It goes the opposite direction. It's not, nothing is upside down, flipped. You're not finding Jurassic below the Cambrian at the bottom of the Paleozoic or something like that. You find instead that the Jurassic is below the Cretaceous, which is below the Cenozoic, which is below the glacial debris at the very end of the Cenozoic, just as it is in continental Europe. And so when we take this conceptual diagram, right, the geological column is not a place that you go to visit. But there are places around the world where you can see lots and lots of it. In South Dakota, basically, we had everything except for the Silurian. There's one little unit down here where we have an erosional space, and there's none of those fossils, but we could follow everything else in the predicted order. So that gives us tremendously good confidence that what we see in one part of the world corresponds well, and that the geological column does have an order to it. This is observational science, right? This isn't interpretive historical stuff. The interpretive historical stuff then gets to be, how did that column get built? How quickly? When? What were the models for why? But the sheer basic observations of, we have these rocks, we have these fossils, and they're found in these stacks and in these orders, corresponds from Europe to the Americas and to Asia and South America and to Africa. So we have a high level of confidence that this column system works and is representing something true about the nature of the world, and something that all of our historical theories will have to take into account.
Right. Well, I know this is not an episode on the Black Hills, but the Black Hills punched up through sediment. Can you just one little bit about what is this punching? I didn't know mountains punched.
Yeah. Okay. So, like I said, if you look on a geologic map of the Black Hills, it looks like this bullseye with your oldest rocks in the center and younger rock progressively to the edges. Now, to the north of us, we have the Williston Basin in North Dakota and a little bit of Montana. And as a basin, it's oriented in the same way that Tom was talking about with Paris. These are old, and the middle becomes progressively more recent. So when we talk about these mountains punching up, what we're talking about is the formation of the Rocky Mountains. And to give your viewers and your listeners kind of a mental picture, think of North America as a big continental unit, and off of the west coast there is an ocean crust plate that is sinking underneath North America.
Right.
Okay, it's what we call a subduction zone.
Yep.
And at this subduction zone is causing the middle part of what's now the Dakotas and Utah and Texas and whatnot, that middle part of the country, to flex downward. It's forming a large basin. And in that basin, sediments are accumulating. When the Rocky Mountains first begin to lift up, it's because there's a detachment, part of this big slab of ocean crust that's gliding underneath the continent, gliding being a technical term for really moving.
Yeah.
Roughly
gliding. Yeah.
It breaks and detaches and sinks somewhat quickly down into the mantle. And that causes the North American continent to begin to rebound, to rise back up, because there was kind of this suction effect that was pulling it down, making this basin. When the plate detached, that suction was released and the continent began to rise back upward. And we see the draining off of the ocean. And along with that, there were a series of large earthquakes, faults that pushed deep rocks up vertically through the overlying sediment. And so you have these very deep, ancient Precambrian rocks in places like Colorado. If you've ever been in Colorado, it's flat like Kansas, and then there's almost this vertical wall of rocks.
Yes.
And the Dakotas are formed at the same time under the same types of circumstances, the Black Hills, I should say, where you have these big faults that drive deep crystalline basement rocks vertically up through the surrounding sediment and push it out of the way. So that's what I mean when I'm talking about this punch. Okay. And geologists will talk about that sort of terminology, not in the technical papers, but in classes when we're talking about what's happening with Rocky Mountain uplift. It's a big punch vertical upward that then displaces and pushes all of these overlying sediments off to the sides.
All right. Well, thank you for that explanation. Sounds like the Black Hills needs to be an episode in the future of.
It's punchy. I'll tell you that.
I guess so. I'm glad to know. It sounds like I am not in danger of being punched by a mountain here in Tennessee.
No.
Okay, good.
Very different.
That's a relief. Now, so let's get back to the Paris Basin here. I understand this basin is not restricted to just the Paris region. Paul, you also went to this meeting to talk about the geology. Well, obviously,
I did.
You went to the meeting to talk about the geology. Could you tell us a little bit about the Paris Basin as it extends across the channel there?
Yeah, so it's very interesting that here in southern England, we have what is in effect a continuation of the Paris Basin. There are actually two basins here in southern England. One is called the London Basin and the other is called the Hampshire Basin. And they were originally part of that single big depositional basin that was continuous with what we saw there in France. The London Basin is basically centered on the city of London, but it extends out to the west and you can also trace it out to the east coast where it kind of goes into the North Sea. The Hampshire Basin is a very extensive basin that covers much of southern England, the rocks along the south coast, including the rocks on the Isle of Wight, which is an island just off the coast of the southern coast of England. And both of these basins, just as the Paris Basin is, they're full of sediments. So there are Cretaceous rocks, and then above the Cretaceous rocks, there are layers of Cenozoic sediments. So very similar to what we see in the Paris Basin. And the reason we have these two basins, the London and the Hampshire basins, is because there's a kind of a fold, a crumple called the Wheel d'Artois anticline that has been pushed up, this kind of ridge of rock that's been pushed up and formed these two sort of structural depressions. And the tertiary rocks that were present there have been eroded away along that sort of uplifted area. So we now have these two sort of separate basins that are separated by this arch of rock. But what we see basically in these basins is very similar to what we see in the Paris Basin. Cretaceous chalks eroded, and then we have tertiary sediments on top. And again, actually, we're missing, just as we're in the Paris Basin, we're missing some of the very oldest tertiary rocks. I think they're sort of present parts of the North Sea area, but they're not present on the mainland.
Okay.
Very similar situation.
So for our American audience, could you tell us which way is the Hampshire Basin from London?
South. Kind of south and west. Yeah, south and west
from there. Okay, good. Thank you. Because Americans,
our geography of the old world is rather limited.
Yes.
Yeah.
It's bad. Anyway. All right. So there you go. So I guess our takeaway lesson here for this first section is that there really is this order of the fossil record and the succession of the fossil record, and we can't just shrug that off as kind of fabrication. It is not something that a bunch of evolutionists came in and imposed on the record. There really is an order, and it was, as far as I understand it, it was established long before Darwin. As Tom, you were mentioning, Cuvier was studying these sediments in Paris and figuring out the order of the fossil record there.
And in fact, there was a guy called Thomas Webster who published in 1814 on the sediments of the Hampshire Basin here in southern England and the fossils in those sediments. And he was able to correlate those sediments and the fossils they contain with the sequences that Cuvier was demonstrating in the Paris Basin to show that there was this continuity. And in fact, it was one of the first examples ever of being able to correlate rocks across kind of international boundaries.
Wow.
So it was historically significant.
That's across the channel too. I mean, you're kind of, it's quite a distance there and quite a change in geography. And when was that happening then?
That was 1814. Cuvier, I think he was publishing in about 1808, 1811.
Right.
There was an initial publication, 1808, Webster just after that.
Yeah, and of course you add into that folks like William Smith in England, who created the first geological map and did these massive correlations. And he was cast aside because he wasn't part of the intellectual elite. He was a foreman on engineering stuff, building out railroads and canals, and I should say canals mostly in that. But I mean, he saw more rocks than anybody else, but because he didn't come from the upper crust of society, he was completely ignored for decades. You got people like Adam Sedgwick, who was Darwin's own professor of geology, right? These are the guys a generation or half a generation before Darwin who are putting together this whole system. So it's not based on evolution. That's for certain, right? This was built by people who were what we would probably call today, various types of old Earth creationists, or even some who were young Earth creationists who, might have eventually moved into something like an old Earth creationism. Dominantly old Earth kind of catastrophist positions without an idea of the common ancestry of all life, right? The big evolution definition that just wasn't in the cards at the time that that this thing was built. Darwin used that. He said that evolution is the explanation for why those patterns exist.
Right.
Ultimately,
right, which is different than saying I need evidence for my evolution, so I'm going to interpret the fossil record this way. It's fossil record was already the way it was, and Darwin came along and said this is why fossil record. That's totally different way of doing things.
Yeah.
Now, while you were
admitting that it wasn't great evidence for him, right? He was setting up a very macro picture.
Yes.
In using the fossil record, while admitting that on like virtually any of the details, this wasn't great.
Yeah. It was a mess. And part of his book is explaining why we shouldn't expect the fossil record to be better. Which always struck me as a very odd thing for a model to model why there's not enough evidence for the model. My model predicts there shouldn't be very much evidence for my model. Well, that's a strange model, but okay, sure. All right. Well, let's move on here. You guys, another one of those things that we creationists get criticized about is we're always just sitting in our armchairs reading books and not actually doing any science. But I understand you guys went out and had an actual field trip looking at rocks. Tom, can you fill us in on some of the details there about what you did?
Yeah, well, I would encourage everyone to go out in the field and look for a proper excursion, because if you like to learn geology and paleontology, you have to go out in the field. So every time I take out students and pupils out in the field, it is a magnificent experience if they really are observing the rocks and trying to envision what could have been happened there. And you have this fascination with children, with students, but also with professionals, and you're just wondering what happened here. So that's really the science all about. So I took the group out in Paris. We looked for several historic exposures, but they were not always there. So that was the big effort from us was to finding the right exposures. And luckily there were still some quarries that were able to visit. And very important for that is that they are maintained. So often within 10 or 20 or 30 years, a quarry is disappearing because of vegetation, because it has been a dump for all sort of things. But we're able to find at least one quarry, a trail, where we were able to go through a whole succession of layers where you start up with the Cretaceous and you get an invasion, so the sea is entering. But then there's a whole sequence of sediments where you finally they are becoming more and more terrestrial. So the first layers they contain marine sediments. Then afterwards you find lignite. So there's that are remnants from trees. So wood, fossil wood, and above that there's limestone, and even furthermore there's gypsum. So where actually the invasion was totally cut off the sea, and you have the drying in of water. So basically, Paris, the center of Paris, is being built on limestones and gypsum, and that is very. Those are actually very dangerous rocks to live on. And the funny story is that Paris has been in danger because people were actually excavating the rocks they needed for their own house. Imagine that you would like to build a house, and you said, well, let's dig a cave and get the rocks out of it, and let's build that house. Now, in the end, underneath Paris, that was one big cave, and there were lots of parts where streets were just collapsing, and you have large sinkholes. So they set up a special department in order to prevent Paris to vanish from the earth, because there was much too much mining, because everyone wanted to live and get rocks out of the. So that's a very funny story. But at the end, so you end up with Paris. There are lots of caves underneath, and I looked with a colleague to find interesting spots to go there with also the excursion group. And one of the major caves underneath Paris is a graveyard. So actually, it's full of skulls, and so we decided that was not the place to go to with the group. But okay, in the end, we had this trail, and that was very good for the people to find all the successions of layers, how actually you get a marine environment turning into a more continental environment. So that happened there, and we were able to look at the rocks, at the sediments, and to envision that. That was one thing. And the other thing is that we actually, on the second day, we went to the a museum in the center of France, which has a large collection of all these historical sites. Those sites are no longer visible, so they railways, highways, houses. So a lot of things get actually lost. That's a pity. But a lot of fossils and also the information is stored in this museum. It's called the Grand Paras d'Evolution. It's a zoology museum, and you find a large exhibition with a lot of mammals as a tribe coming out, something that is called the Grand Paras d'Evolution. And the nickname for the layman is that this was the great exit from the Noah's Ark. So that's the funny part of the story. But we were able to connect to those fossil locations and on the second day, and actually to see the fossils which are no longer to be seen in the fields. So you have to imagine, if you are working in on mammals, on fossil mammals, it's very hard to find fossils. So they are scarce because a lot of animals which are dying on land, they are not being preserved as fossils. So you get a very few percentage of them will become fossil. So the amount of information is scattered, and the amount of fossils, they're very precious. So you can't find them like you find the marine fossils like this. They're in great abundance, and you can carry them and yourself, or you buy them. There's lots of fossils, but with the mammals, that was our primary topic. You can't just find them out in the field. It's no longer there. So you have to go to that museum and to look at the rocks. And therefore, we also invited Marcus Ross, who is a macro paleontologist. I'm a more in between. I'm a general paleontologist, sedimentologist. And Marcus also was able to go through those several collections, and that gave us really insight what was happening there. And the big picture is, and I think Marcus will elaborate on that, is that you find mammals in the Paris Basin. The lower part, which we call the Paleocene, it is a bit different than what is found higher up in the Neogene. So there was a time during the Tertiary when there was a big movement. Lots of animals came in from different continents, especially North America, and you get a change in fauna, and that is also an important aspect of the whole story. So if you just start off with the idea, well, this is the key of, here's the answer of our question, what's the origin of mammals? We have to disappoint you, because actually the key is probably somewhere else, because it came from outside. And here we get into a very different situation. So perhaps when you, as a listener, you will start, well, what happened there in that basin? Was that supposed evolution or something like that? Well, there's more to it. In the end, what you will see if you go through the tertiary, the basin, and if you look also to the fossils in the museum, there is definitely there is a development. So in the first part, you find different mammals than in the upper part. And there's also a change in the number of species. And I think that is a different story.
Okay. All right. And Marcus, did you want to elaborate anything on that?
Well, one thing that I can totally agree on, or plenty of things I can totally agree on it. The field excursions were great. They were fantastic. The geo walk that we got to go on and bringing us from Cambrian up through a variety of Cenozoic deposits was really, really good, because again, you're getting right out there, you're looking at the data, you're looking at the sediments themselves, and seeing the connections between these different layers of rocks, the types of fossils that are found in them. Right, I'd shown, for example, these little echinoids that were found in the Campanian rocks in the Cretaceous, but you don't find those higher up. You find different types of fossils. Tom's been showing you some of the fossils that he's got as well. I've got some from the same. We visited a location dug into an Eocene kind of marl chalk. It's kind of like a muddy chalk type of material, and it's got just millions and millions of these fossils, and many of them are excavated in place so that you can actually see the fossils where they lie in the rock themselves. This whole cave system was built into the hill in order to age champagne. But the owner of this area loves his fossils so much that they excavate the fossils and they prepare some and they sell some, but they also just have galleries and galleries and rooms as you're taking this big long tour with all these fossils that are prepared right in place, which is just astonishing. The pictures that I pulled out of there are just, I still look back at them and I'm like, I can't believe what I'm seeing, especially because one of the most famous fossil from that cave of shells, as it's called, translated in English from the French, are these snail shells that are literally, almost half a meter or so in length. I mean, for us Americans in here, like 1.5 to 2 foot long snail shells. They look like conch shells out of the Caribbean, but long, and would have had a sea snail inside it. Mm-hmm. It's only found here. There's no other place in the world where you've got these particular species with these gigantic shells. And I only brought a carry-on, out to France, so I couldn't bring one of these things back with me. Of course, they cost like €300, but whatever. I bite the bullet, get the thing.
Yeah.
It was some of them are like €900. I mean,
you can
really
buy
nice
new clothes, man. I mean, come on. Have some priorities here.
What are you saying? What are you saying, Todd? So I picked up a couple of those fossils as well, but you're in the geological context. I mean, in this cave and at that geowalk, you are literally like inside the geological context for these fossils.
Just to clarify here, because I think I heard you say this, are there barrels of champagne in there that are aging? Is that what's going on?
Bottles
or something?
Bottles
yes. Of champagne. Okay.
Yeah.
Pardon me. I'm not a French wine connoisseur here, but okay. So there is champagne.
Neither was I, but there was a tasting at the end of it. So why not?
All right.
But
cool.
But yeah, so I mean, really neat that you've got this cave doing dual purpose. It's making most of its money from champagne aging, but it's also selling prepared fossils and doing tours. And then going to the museum was just such a special treat to be able to see these fossils that were first discovered in places like Paris. Or for me, I've talked before, I studied mosasaurs for my PhD work. And at the Musée d'Histoire Naturelle in France is the very first recognized mosasaur fossil that was stolen from the Netherlands, where Tom is from, stolen from Maastricht by Napoleon's army and dragged over there because Cuvier wanted it. Spoils of war. He wanted this grand animal of Maastricht, as it was called. And so I got some pictures of that. That this was one of the animals, along with some of the others that we saw there in Paris, that were driving Cuvier to the conclusion that things have gone extinct.
Yeah.
That there are organisms in the geological context of the Earth that aren't alive today anywhere.
Right.
And something like the Mosasaurus, as it eventually was named by an English guy, was something. It wasn't a whale. It wasn't a crocodile. It looked like a lizard, but it's gigantic, right? That the skull is like 3 feet long. What is this thing? And so it would be those sorts of things and some of the early mammal fossils that we came to look at that would drive this discussion of the concept of extinction. Not just that people might have driven something extinct and we hunted off all of these, predators in an area, but like nobody's ever seen anything like this before. That was very shocking to people at the time who believed in a principle of plenitude, as it was called.
Yes, that's right.
That God would have allowed everything that he had ever created to continue and persist. And, making kind of a connection back to the Americas about that, if you read some of the writings of Thomas Jefferson, as he's writing to Lewis and Clark about their expedition to go to the American West and to reach the Pacific, he is hoping that they will find mastodons and large extinct lions and other animals that are being found as fossils on the East Coast, because he's still got in his mind a little bit of this principle of plenitude, that they're still out there somewhere.
Yeah.
And you get movies like the original Lost World, Sir Arthur Conan Doyle, right?
Yes.
With this idea, maybe somewhere out there, they're still around. So those connections, for me, as somebody who grew up in the New World, to go back to the Old World where all of this was done was just such a spectacular privilege and a treat.
Yeah, that's amazing. So why don't we shift gears here? So we've talked about the bowls, the sort of the basin deposition, which looks like a stack of bowls. And we have the oldest stuff on the outside of the basin, and it gets progressively younger the farther in the center you go. You guys apparently went down into caves and dug out actual, I guess I'm not sure what to call them. They're more like mine shafts, I suppose, where people have dug out stuff to look at the material actually in situ there, in the actual rock itself. And we've affirmed that there is an order to the fossil record that is quite independent of whether evolution is true or not. Okay, so what is this supposed to mean? Does this prove the flood, Paul? Are we done now? Can we go home? And have we proved the Bible is true?
Yeah, what does this all mean, basically, for the creationist sort of view of Earth history? I think one place to begin is to think about the patterns that we see in these rocks, because I think there's a kind of coherent picture, and I think we see it in both the Paris Basin and also on this side of the English Channel in the London and Hampshire basins, where we can discern this shift from marine deposition to more continental deposition through time, through the Cenozoic. And that's really important. So think about those Cretaceous chalks that we saw in the Paris Basin. They sit underneath the tertiary sediments. The Cretaceous rocks testify to an episode in Earth history where there was widespread marine deposition across the continents, not only here in Britain and in Western Europe, but actually in other parts of the world too. Those Cretaceous chalks underlie much of Europe, the Netherlands, Denmark, France, England. You can actually see Cretaceous chalks in the same part of the geological column in North America. You can see them in South Dakota. You can see them in Texas, the Austin chalk in Texas, the Selma chalk in Alabama. If we go eastwards from Europe, you can see those same chalks in Turkey, There are even some Cretaceous chalks in Western Australia. So this is an incredibly widespread marine unit found across the continent. But then what happens during the Tertiary? So, if we kind of go up in the sequence of rock layers, what's above the Cretaceous? Well, we seem to see there a kind of scaling down of marine deposition. So here in sort of Western Europe, much of Britain at that time becomes dry land. It seems to emerge above the ocean waters. Marine deposition seems to be concentrated more in the North Sea area and in the lowlands of Western Europe, the Netherlands, Belgium, and in France. But certainly here in Britain, it seems to have been a time of uplift where the Cretaceous chalk was being eroded, subjected to erosion, and across quite a broad area. And then through the Tertiary, as we go up through those Tertiary rock, we see a kind of interplay between marine deposition and non-marine deposition. So sea level seems to be fluctuating, oscillating, and we're getting sort of periodic advances and retreat of the sea into the area of southern Britain and the Paris Basin. So what this results in is a kind of series of vertical changes in the rock layers, where we switch from marine sediments to brackish water sediments to freshwater sediments, and then back again. And you see a number of these switches from sort of marine to non-marine deposition, but with a general trend of waning marine influence as you go up through the sequence. So this seems really significant that from the end of the Cretaceous onwards, we seem to have this shift away from marine deposition towards more continental deposition, and certainly in Britain, from about the mid-Tertiary onwards, southern Britain was basically dry land for most of that. That seems significant in terms of the flood. Where do we put the end of the flood? I think when we look at the rocks of the Paris Basin and the London and Hampshire basins, it gives us some clues about where we can put that boundary. There are some other things I'm sure we can talk about. But,
you say England is basically dry land. Then are there just no rock layers left then? There's just nothing else happening?
Well,
what's going on?
We get some non-marine sediments that are laid down, in rivers and lakes and things like that, with non-marine fossils in them.
Okay.
And sometimes we don't get any sediments. Sometimes we have a hiatus where just erosion is happening.
Yeah. Can I say something, Todd?
Yes, I was going to ask you next.
Because I think so far we have been talking a lot about geology. The theme of the conference was also partly a biological one, because we are confronted with this rapid development of mammals, and we had also a number of professors at our conference, biologists, and they had been asked to give an answer to the question: is it possible, also within the framework of a creation-minded person, to think about a fast radiation? And that's a difficult question. So if you look at genetics, epigenetics, genomics, etc., we had a lot of expertise at the conference. And basically, this is a growing field of investigation, not only for secular scientists, but also for Christian-based scientists. And I think we're still waiting for some answers, but at the same time, there are some promising answers. So one of the things, also the key circumstances, is that we have a low number of individuals. So if you start off a Noah's Ark, the population genetics is probably that we have a lot of land area available. Species are moving very quickly. That can happen. We see that today also. For instance, if you look at the wolves in Europe, they are tremendously fast expanding at the moment, 500 kilometers in one generation. And well, the key circumstance is that after the flood, you have a situation where the populations are very limited. So what kind of pressure put it on genetics? That's an interesting thing, a theme very, very, very important. At the same time, yes, we have a lot of similarities between, for instance, North America and Europe. If you look at the ecosystems, they are smaller. Also, the type of sediments to tertiary basins, like the Bridger Formation, is also very continental, very low, smaller deposits with a lot of fossils in it. We find the same type of sediments in Europe. But there's another key issue, is that there has been a lot of interchange. There has a lot of movement between the continents, and that's the story. It's difficult to find out what happened there. And sometimes we also are confronted with difficult questions. For instance, if you look at the marsupials, at present we do find them in Australia, only in the uppermost layers. They should have been moved either through North America, South America, Antarctica to Australia, but Australia has never been attached at the latest phase to Antarctica. So there's a big question mark. And if you go through a different route through Asia, that's also not possible. We could spend a whole new episode at your podcast about that problem. But we're facing many problems. How actually did the mammals arrive on the spot? And I think, Marcus, you did a very nice introduction, a very nice contribution to the conference, where you discussed where should we put the boundary in the geological record, looking at the fossils of the mammals. So what criteria one should use in order to discern what could be the level where we have a change from victims from the flood into the new habitants coming from the ark. And that's was my original, as an organizer, my original perspective. Could we shed some more light on that question?
All right. Well, Marcus, I
thank
guess
you
that's
very
up to
much.
you then.
Yeah,
Good
thank you
lead in.
for the compliment, Tom. That's
I
very
give the
kind
ball
of you.
to you. Yeah.
Yeah, and obviously, or for those who've been longtime listeners and watchers to the program, Todd and Paul, you've had a whole series on the post-flood boundary, featuring myself and Tim Clary, representing a couple of different perspectives common in North America between a flood boundary somewhere just above the end of the Cretaceous, which would be what I favor, and one that's slightly below the Ice Age, which would be what Tim Clary favors. It would have been like the historic Whitcomb-Morris perspective. But yeah, so one of the things that I was doing at the conference was presenting a particular case for understanding the mammals, because my initial paper about understanding the flood boundary used North American mammals back in 2012, and that's been debated somewhat heavily in the creation literature. In Journal of Creation, there was a back and forth with myself and Taz Walker. Mike Ord has written papers and even replicated my original study and updated it, and it came to the same. He didn't come to the same conclusions. He got the same results out of that. He interpreted them in a completely different fashion, but he found the same sort of situation where we have multiple genera within a particular family that might cross any boundary that we would draw, probably anywhere above the Eocene at least, and probably also within the Paleocene. And I think this dovetails well with what Paul was mentioning about, this general reduction in the amount of marine influence in the area and the interplay of what looks like very terrestrial sediments. Tom, you mentioned the Bridger Formation here in the United States as a good example. We do see basins. Now, the Paris Basin's a big, big basin, and it includes huge amounts of sediments going deep into the geological column. What we find as we move into the Cenozoic, that we have these smaller basins that are isolated from one another. And when I was in South Dakota, we were next to Big Badlands National Park. If anybody's driven through that, it really is big, and the land really is bad. It would be a terrible place to have to try and live, but there's great fossils in that area, and that's a basin that has some boundaries and edges to it that separates those Eocene and Oligocene, those Cenozoic sediments, from places like the Bridger, or from places like Ashfall in in Nebraska. There might be some of the same underlying rocks in the Cretaceous or the Jurassic or the Paleozoic underneath all of that. But then when you get to these particular mammal-bearing units, the fabric of the sediments is distinct from one basin to another. It's not the stuff that's covering a third of a continent or crossing over, from England to France. You don't see that sort of thing. These geological features are far more restricted and localized in bringing in that terrestrial sediment that Paul was mentioning, Todd, to answer your, like, how do you get sediments on the continent? Well, if you got a low spot in the continent, you're still going to get erosion of that. You think of any lake that is built here in the United States becomes a depositional center for the rivers that are bringing in sediment. It gets piled up inside the lake, and eventually you have to dredge or the lake fills up. And that's what's happening on a larger scale in these basins, but not on the massive scale that we see in what at least all of us tend to agree are flood rocks, even if we're disagreeing about what are post-flood rocks. So the mammals within young Earth creationism are an important player in trying to see what's going on after the flood. Are these flood deposited or are these post-flood deposited things? And when you have multiple genera that are passing through potential boundaries, and our conception of what a biblical kind is bigger than a genus, it's usually like a family or a subfamily, something like that, then that would mean that Noah was bringing multiple members of a kind that are probably interfertile with one another and then releasing them after. That doesn't make a lot of sense, right? If you've got 5 or 6 different kinds of cats that cross the boundary, but we know from modern breeding that a bunch of them are interfertile, then we have to knock down the location of the post-flood boundary to account for the diversification of those kinds. And as we've already established, the geological column is in fact a reality. So arguments that it's generally correct, but it's got lots of errors in it, or that it's fudged around the edges to make it work with evolutionary theory, is just not what's going on in geology. So we've got to take the data for what they are and evaluate them as best we can. And we were privileged at this meeting to have people talking about paleontology, people talking about geology, people talking about epigenetics, people talking about population biology, and try to get a more holistic approach to the question. Because that's one of the things that I know, Todd, with your work in baraminology, we always want holistic data sets. We want data sets that are as big and wide ranging as possible. And by getting a lot of different kinds of eyes onto this question, hopefully we can build towards a good resolution.
All right. Well, that is a lot. So let me see if I can wrap this up. You guys correct me if I get it wrong. So your conference, you were looking at Paris Basin, which from the surface would look like a kind of a bullseye shaped thing where you have the older sediments on the outer rings, and then as you get closer to the center, it gets younger and more recent sediments.
Yeah.
So that's basically it.
That's
Somewhere in there, there's a transition from mostly marine material to mostly terrestrial type deposition kind of stuff, a little bit. And Marcus, you're arguing that if you look at the actual content of these various basins around there, you're going to see mammals that are terrestrial and likely represent colonizers, basically the recolonizers after the flood. Is that what's going on?
Yeah, colonizers and migrants.
Okay.
Tom mentioned the difficulty of seeing where the evolution was happening, right? Where did these mammals come from? We actually have a similar situation in North America. There was so much interchange throughout the Cenozoic between North America and Europe that we're constantly getting each other's migrants. and also a connection in North America to Asia from time to time as well. So like the American bison, it ain't American. Yeah, we got that from Siberia.
What?
Yeah, I know.
What?
Yeah, well, hate to burst the bubble on that
It's
one.
a Russian
that's a very
spy? This is bad.
yeah. Either that or it came in from China. We get everything from China anyway.
Man.
So.
Yeah, we do. All right. Well, that sounds pretty good. All right. So that is last year's meeting. Is there another one coming up? Can somebody give me the details on this year's geology
Well,
workshop?
we I have been asking around with the lecturers if we should come out with a booklet. I think that should be a good thing because the topics we discussed are questions that are very general. Lots of lots of Christians also are the scientists especially are bothering about these questions. So I think I personally I would like to write a little booklet together with the people who actually were leading the conference. Another thing which I also like to mention is that within a few months I like to relieve the videos of the conference, so they will be available online, and that is also interesting. So the talks of Marcus, myself, Paul, etc., all those people are going to be available. After the conference, we had a post-conference fieldwork where we decided that we should pay attention to the Cretaceous, the chalks of in France and England and in Germany. So and make a work group. That will probably take a lot of not a lot, but some years if to produce something. I do hope we can work together with a few people on a more regular basis on the topics and the questions we have. So I would really salute if we were able to discuss things in a more global way where we have input from you, from the United States. People are really making good contributions as well as in Europe. I think we need it because there's a lot of data. There are very few specialists to interpret those data, and definitely we need to sharpen the discussion to have a better outcome so far. So I'm not satisfied with what we have at present. I do hope that we're able to produce more answers on the questions we have today.
All right. And then
Yeah.
the fall meet, is there another fall meeting coming up here this year?
Yeah, well, this meetings from what I've recent they are on an annual basis. So next year's will be in the south of Germany, a totally different topic.
Okay.
The thing I actually I proposed the conference theme and the way we treated it more with as a theme. I think that has been very productive. So a lot of conference you see that there are just a variety of topics which is not helping very much to solve the questions. And if you center on a specific problem, that could be, I think the outcome is much better. I think I also imagine that there are a lot of interesting topics to be discussed between American and European geologists. We share a lot of geology, and of course it has been by plate tectonics, there's a distance, but in essence, there's a lot of similarity, and we should come together more often.
Yeah.
And I would really salute that.
I would
And
love that.
we can put a link in the show notes, can't we, to Vorten Vissen's website and the details of the conference. But there will be another one this autumn, and I hope to be there. Yeah.
Oh, great.
Yeah,
all right.
And actually, I'm also attending the biological Fachtagung from Vorten Vissen. Vorten Vissen is sharing a lot of conferences on specific topics like geology, but also biology. And this weekend, I will be in Germany giving a lecture on Paris Basin as an introduction. And also, we have some lectures on the topic of the diversification, the special radiation of mammals. So the topic is still around, and we have still have we need in need of a lot of answers.
All right, that sounds great. All right, then I think that wraps up this episode. I guess. Thank you very much to all of our guests who have joined us. It sounds like you guys had a pretty good time over there in France, touring champagne production facilities that actually are full of fossils. So that's kind of different.
Can I give you can I say one little story? So
sure.
Do you know why there is champagne? Have you ever asked
Not
yourself
really.
that? Why is there champagne?
Nope.
That is because in England, the young people at the kings and the son of the kings, they were a little bit bored and they needed a new drink. And they asked something, let's have wine with bubbles. And they asked the French people, can you make some for us? And they made the champagne, and that caused the big, well, it was a real big thing at that time. The real thing, because champagne is really being there because of a request of the English throne. So
We are.
all
Wow.
that's for Paul. He is actually, the English are the cause of beer of champagne at
All
the
right.
end.
I had
But
no
it's
idea.
but it's the local geology that
Yes.
makes
The
it all
local
possible.
geology, yeah.
That
So
makes it possible.
the fields of grapes, and I've never seen so many grapes in my life. It was just incredible, just driving for miles of nothing but vineyards everywhere.
Yeah.
Yeah.
And it's, these are largely built on these Campanian chalks.
Yeah.
They are. Yeah,
And
sure.
grapes are highly susceptible to flavor changes on the basis of the underlying soil, which is controlled by the geology and the climate of the environment. So if you went to a Geological Society of America meeting, or certainly those in Europe as well, very frequently, if they're in anywhere around wine country, there will be geology of the wine tours areas, because after all, the geologists, they want to learn more about the geology of the area and sip happy drinks
Sure.
while they
Yep.
do it. So yeah, anytime it's
Sure.
in
Yep.
Virginia or California, if you got something in France, there's always going to be geology of the wine country tours. But it's because grapes are just very, very sensitive to the soil conditions, which are all controlled by geology and rainfall. So yeah, thank you for the Campanian for providing the opportunity for those French to bless the British nobility who needed a fizzy drink.
We will invite you one more time in these difficult times. Come over to Europe, and we'll welcome you.
Well, I'm
Sounds
glad
good.
you're still
Sounds
welcoming
good.
us. All right. Well, thank you, everybody,
That was
again. We are at the end of our episode here. Paul, as usual, we're not sure what the next episode will hold. I'm sure it will be a surprise and very interesting, as they always are. So we will see you again next time on Let's Talk Creation. Thanks for watching.
Yeah.
Au
We'll see you
revoir.
then. Au revoir.
Au revoir.
Thanks for listening to this episode of Let's Talk Creation. For more information, visit us at letstalkcreation.org, where you'll find an archive of past episodes and all our show notes. If you'd like to leave a comment or make a suggestion, you can find us on all the major social media platforms. Let's Talk Creation is brought to you in the U.S. by Core Academy of Science and in the U.K. by Biblical Creation Trust. As a listener-supported ministry, we are grateful for all of your financial support. Find out how you can make a contribution at our website, letstalkcreation.org. Also remember to like, subscribe, and share this episode with your friends. Thanks, and see you next time.